All right, let's get started. Hi, everyone. I'm Toni Breshears, and this is my Module 3, Chapter 4 and 5 lesson presentation over number theories and integers. So let's get started. All right, question 1. Use the divisibility test to decide which of the numbers 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is a divisor of the given numbers in the table below. So we're going to be testing these numbers up top: 684, 2064, 51,051, 644,490, 2,676,740, and 50,250,528. So we're going to start off by testing whether these numbers are divisible by 2. Okay, so to test if something is divisible by the number 2, if the last digit is in the number is even, then it is divisible by 2. So 684, its last digit is 4, so that is even, and so it can be divisible by 2. It is divisible by 2. Same with 2064. It ends in a 4, which is even, so it is also divisible by 2. Now, 51,051, it ends in a 1, which is an odd number, so it is not divisible by 2. Now, 644,490 it ends in a 0, which is an even number, so it is divisible by 2. And same with our next number. It is also ends in a 0, which is divisible by 2. And then now we have 50,250,528. 8 is an even number, and so it is also divisible by 2. Okay, now on to the number 3, testing to see if our numbers are divisible by 3. So you add together all the digits in the number, and if its sum is divisible by 3, then your original number is divisible by 3. Okay, so what we have is 8 plus 4, which is 12, and then 12 plus 6 is 18, and so 18 divided by 3 is 6, so that gives us divisible by 3. And then same with 2064. 4 and 2 is 6, and 6 plus 6 is 12. 12 divided by 3 is 4, so that is also divisible by 3. And then here we have 5 plus 5, which is 10, and then 1 plus 1 is 2, so 10 plus 2 is 12. Divide that by 3, and you get 4, which means it's still divisible by 3. And then here we have a 9, 6, 4, 4, 4. So 3 times 4 is 12, and you add 9 to that. Well, we'll do 3 times 4, which is 12, plus 6, which is 18, and then you add 9, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. 27 divided by 3 is divisible. It's divisible. And then when you add up the rest of the numbers, our 2,676,740 is not divisible by 3 when you add up its numbers and divide by 3. And then with our 50,250,528, when you add up its numbers and divide by 3, it is divisible by 3. Okay, so now on to 4. So for our numbers to be divisible by 4, the last 2 digits in the number can be tested, and if they are divisible by 2, then the entire number is divisible by 4. So 84. That's divisible by 2 because it ends in an even number. So it is divisible by 4. 2064, it is also divisible by 4. 51,051, it didn't work for 2, so it's not going to work for 4. And then now 644,490, it also works because it ends in an even number, and it worked for 2. And our next number also worked for 2, so it will work for 4. And then same with our 50,250,528. So now on to 5. If the numbers end in a 0 or a 5, then they are divisible by 5. Okay, so 684 ends in a 4. It is not divisible by 5. 2064 ends in a 4. It is not divisible by 5. 51,051 ends in a 1, so it is not divisible. Our next number ends in a 0, so it is divisible by 5, because if it's a 0 or a 5, then it is divisible. All right, and then our next number also ends in a 0, so then it is divisible by 5. But our last number ends in an 8, and that is not a 0 or a 5, so it is not divisible by 5. Okay, so now testing for 6. If the number is divisible by 2 and 3, then they are divisible by 6. If they are divisible by only one of the two, then they are not divisible by 6. Okay, so going back and looking at the last one, 2 and 3. 684 was divisible by both. 2064 was divisible by both. 51,051 was not divisible by both. 644,490 was divisible by both. And then 2,676,740 was not divisible by both. And then 50,250,528 were divisible by both. So the only numbers that will not be divisible by 6 are 51,051 and 2,676,740. So we'll go ahead, put those in. Okay, so on to our next one. Let's see. Okay, so now we're going to be testing 7. So you take the last digit off the number, double it, and subtract the doubled number from the remaining number. If the result can be divided by 7, then it is divisible by 7. Okay, so we're going to take the last digit of the number, double it, and subtract the doubled number from the remaining number. Okay, so we have 684. So we're going to take the 4, we're going to double it into 8. And then you're going to subtract the doubled number from the remaining number. So after you do that, 684 will not be divisible by 7. And then same thing, you'll take the 4 off the end of this, you'll double it, which is 8. And then once you subtract the double number from the remaining number, it will not be divisible by 7. All right, now 51,051. When you take the 1, you double it, which gives you 2. Then it's divisible by 7. All right, let's see about 644,490. That one is also divisible by 7. And then we have 2,676,740. That is not divisible by 7. And then our 50,250,528, when we work it out, it is also not divisible by 7. Okay. So let's see. Now, to test for 8. The last 3 digits of a whole number are divisible by 8, then the entire number is divisible by 8. So what this means is you would take 600, you would really just calculate it out how it's supposed to work. Like, instead of doing the tests, instead of doing these tests, you would just go and divide the whole numbers by the number to find out if it's divisible or not. But that's practically what you would do with 8. So what we're going to do is you would do 684, and then you divide it by 8, which gives you 85.5. So it is not divisible by 8. And then when you have 2064, well, 64 divided by 8, because you only take the last 3, so the 0 wouldn't count. It gives you 8, so it is divisible by 8. Now, what about 51,051? So what you would do is you would do 51 divided by 8, and that is not divisible by 8. And then now we have 90. Well, 490, because you take the last 3, you divide it by 8, and you get 61.25. So that is not divisible by 8. Now, next on our last 3 is 740 divided by 8. You get 92.5, which is also not divisible by 8. And then on 50,250,528, you take the 528, you divide it by 8, and it gives you 66. So that is divisible by 8. Now, doing number 9. Here's how you find if the number is divisible by 9. Okay, so add up all the digits and divide the sum by 9. And if it doesn't have a remainder, then it is divisible by 9. So 684, we add 6 plus 8 plus 4, which gives us 18. We know 18 is divisible by 9, because 18 divided by 9 is 2. All right, so now 2064, you add your 2 plus your 6 plus your 4, because the 0 would do it no effect, and it gives you 12. That is not divisible by 9. You would get a remainder. Now, 51,051 we know is also 12, because you add your 2 5s, which is 10, and then your 2 1s, which is a 2, and it gives you 12. So that is not divisible by 9. Now, you have 6 plus 4, 4, plus 4, plus 4, plus 9, which gives you 27. And when you divide that by 9, it gives you 3. So that is divisible by 9. Oops. Well, now we know that 2,676,740 added all up together divided by 9 gives you a remainder, so that won't work. So now our 50,250,520, which is 5 plus 2 plus 5 plus 5 plus 2 plus 8. And that gives you 27. 27 divided by 9 is 3. So now on to the easiest one of all. If there is a 0, this is how you find if it's divisible by 10. If there is a 0 in the ones place, then it is divisible by 10. So 684 doesn't have a 0. 2064 does not have a 0. 51,051 does not have a 0. Now, 644,490 ends in a 0, so it is divisible by 10. So now we have 2,676,740. It ends in a 0, so it is also divisible by 10. And 50,250,528 does not end in a 0, so it is not divisible by 10. Now, for 11, you must subtract and add the digits in the number in an alternating pattern from left to right. If the answer is 0 or 11, then it's divisible by 11. So, how this works. So, what you do is you'll do 6 minus 8 plus 4 gives you 2, so it does not work. And then you do 2 minus 0 plus 6 minus 4, which gives you 4. It's not going to work. And then you do 5 minus 1 plus 0 minus 5 plus 1. It gives you a 0. And that will not, it does not work. Now let's try 6 minus 4 plus 4 minus 4 plus 9 minus 0. It gives you an 11. Okay, so these bottom two are supposed to be correct because the 51,051 ended in a 0, so that one is correct. And then the 644,490 ended in 11. So that one is also correct. I'm so sorry about the mess up. All right, so next try. So we have 2 minus 6 plus 7 minus 6 plus 7 minus 4 plus 0, which gives you a 0. So that one is also correct. And then now for our final one, you do 5 minus 0 plus 2 minus 5 plus 0 minus 5 plus 2, and then you do minus 8. And that gives you a negative 9, so that does not work. Okay, so we know for 11, our 51,051, they work. Even though it shows it does not, it does because it ends in a 0. 644,490, it works because it comes out with 11. And then 2,676,740 comes out with a 0, so it also works. All right, casting out nines. Okay, so this looks like a whole bunch of craziness, but I will explain how it works. Okay, to use casting out nines, first replace every number by its remainder when divided by 9. Based on the divisibility test for nines, the remainder for the sum of the digits is the same as the remainder of the original number. Okay, so what we have here is 416 plus 7,490 plus 69,844. And now without calculating that ourselves, our problem gives us the answer. So it says that our answer is 112,790. Well, casting out nines is supposed to let us know whether that answer is correct or if we need to recalculate the problem on our own. So you take 416, you do 4 plus 1 plus 6, which gives you 11, and then you take 11, you divide that by 9, which is 1.2. So 2 is your remainder. And then you do the next number. 7,490 is 7 plus 4 plus 9 plus 0, which gives you 20. You 20 divided by 9 equals 2.2. Your remainder is 2. Then you do 69,844. You add your 6 plus 9 plus 8 plus 4 plus 4. It gives you 31. 31 divided by 9 equals 3.4, and 4 is your remainder. Now add the remainders and divide their sum by 9. So 2 plus 2 plus 4 equals 8. And then you do your 8 divided by 9, it gives you 0.8. Now, you do what your numbers are supposed to equal. You do the same thing to figure out if that is correct. Okay, so 112,790 equals 1 plus 1 plus 2 plus 7 plus 9 plus 0, which gives you 20. Now, when you do 20 divided by 9, it gives you 2.2, and your remainder is 2. Well, the remainder of the sum of remainders when divided by 9 does not match with the equation's sum remainders, so you must recalculate. Your remainder was supposed to be 8, but instead you got a 2. So that shows you that the final answer is not correct. So what you do is you add your 416 plus 7,490 plus 69,844, and it gives you 77,750. All right, on to our next one. Same thing, casting out nines. So now we have different numbers and a different outcome. So we have 8,550 plus 6,888 plus 2,525 plus 6,029, which tells us it's supposed to equal 23,892. So what we'll do is we do our 8,550, which when you add its numbers together, you get 18. 18 divided by 9 equals 2, but 0 is your remainder. You have a whole number, so 0 is your remainder, and then you'll do your 6,888, which gives you 30. When you do 30 divided by 9, you get 3.3, so 3 is your remainder. Now do the same with the rest of your numbers. 2,525, which gives you 14. 14 divided by 9 equals 1.5, so 5 is your remainder. And then 6,029. When you add up its numbers, you get 17. 17 divided by 9 is 1.8. So 8 is your remainder. Now add the remainders and divide their sum by 9. So when you add them up, when you add your 0, your 3, your 5, and your 8, you get 16. 16 divided by 9 equals 1.7. So now you're trying to get a remainder of 7 with your 23,892. So what we'll do is we'll test it. So you add up your number and it gives you 24. So you do 24 divided by 9, which equals 2.6. Your remainder was a 6 instead of a 7. So the remainder of the sum of remainders when divided by 9 does not match with the equation sum remainders. So you must recalculate. So you'll go and you'll add in your 8. You'll add your 8,550 plus 6,888 plus 2,525 plus 6,029. And that comes out with 23,992. So compared from this to this, your number was actually 100 off. So let's see, on to the next one. Okay, so casting out nines continued. So now we have 783,362 minus 3,674 equals 74,678. So you do your 78,362 divided by 9, which gives you 8,706.8. And then if you do your 3,674 divided by 9, it gives you 408.2. You take the remainder of the two numbers and subtract them. 8 minus 2 equals 6, but 74,678 divided by 9 gives you 8,297.5. So the remainder being 5 does not compare to the 6 we calculated. So the calculation does not add up. Now, when you're doing subtraction, if you see how it happened from our previous, we were doing adding. So you had to take the remainder of the numbers added up. But this, you can just take the whole number and you just divide it by 9, and whatever your remainder is, you use that. So the calculation does not add up. So you do 78,362 minus 3,674, and you come to find out that your number is actually 74,688 instead of 74,678. So it was actually 10 off from what it's supposed to be. So now, on to multiplication of casting out nines. So we have 337 times 620 equals 209,940. So 337 divided by 9 equals 37.4. And then 620 divided by 9 equals 68.8. So you take the remainder of the two numbers and multiply them. So you have 4 times 8 equals 32. Divide the 32 by 9. So you have 32 divided by 9 equals 3.5. Now find the remainder of 209,940 and compare its remainder to the remainder found before. So you have 209,940 divided by 9 equals 23,326.6. The remainders are not the same, so you must recalculate because you got a 0.6 instead of a 0.5. So when you do 337 times 620, it equals 208,940. So this was actually a whole 1,000 off of what the answer was supposed to be. Okay, so let's go on to our next one. So measuring rods. Okay, so the colored rods shown here are 1 centimeter square and of lengths of 1 centimeter to 2 centimeter to 3 centimeter and so on till we get to 10 centimeter. So as you see here, that's a 1 by 1, a 2 by 1, a 3 by 1, a 4 by 1, 5 by 1, and so on. Okay, so we say that a rod measures another rod if a number of the rods placed end to end are the same lengths as the given rod. Okay, so how to find which rods will measure up to another? The number of rods will be multiples of the other. So A, multiples of, it says show which rods will measure the 9 rod. Okay, so you have to find what its multiples are. So what makes up 9? We know 1 times 9 equals 9, so 1 and 9, and then 3 times 3 gives us 9. So multiples of 9 is 1, 3, and 9. I don't know why those aren't staying, but anyways. So you'll have one of these, you'll have 1 of your 9 by 1s and 9 of your 1 by 1s, and then you'll have 3 of your 3 by 1s. Okay, so now multiples of 6. So we'll do the same thing. What numbers multiplied together equal 6? So we know 1 times 6 is 6. 2 times 3 is 6. So out of that, we get our multiples are 1, 2, 3, and 6. Okay, so this one actually stayed. So we'll have 1 of our 6 by 1s, 6 of our 1 by 1s, 3 of our 2 by 1s, and 2 of our 3 by 1s. Now, greatest common divisor of 9 and 6, the largest number that goes into them both. Okay, so we know 1, 3, and 9 goes into 9, and 1, 2, 3, and 6 goes into 6. What numbers in the multiples are the same as the other? Well, I see 1 and 3. So which one is the largest? 1 and 3 go into them both. 3 is larger than 1, so it is the greatest common divisor. Now on to D. Place the 10 rod and 8 rod together to make an 18 rod. Find multiples of 18. Okay, so 1 times 18 equals 18. 2 times 9 is 18. And 3 times 6 is 18. So we'll need a 1 by 18, an 18 by 1 rod. We'll need 2 9 by 1 rods, 3 6 by 1 rods, and then 6 3 by 1 rods, 9 2 by 1s, and then 18 1 by 1s. So that is what this looks like. So in E, we show all the lengths of all the rods or trains which can measure the 18 train. So here I put a 10 rod and an 8 rod together to show us our 18. Here's our 18 1 by 1s. Here's our 2 9 by 1s. This is our 9 2 by 1s. This is our 6 3 by 1s, and this is our 3 6 by 1s. Okay. And then let's see. All right, so least common multiple. So here we have finding the least common multiple, we're going to be using prime numbers. So our LCM, the numbers that we're going to be finding the least common multiple of, are 48, 25, and 65. Okay, so using prime numbers, we'll start out with our 48. You can do this in any way you want. So starting out with 48, I decided to do 48 divided by 3. Well, when you do that, you get 16. And as you go down the line, if it also goes into your other numbers, you can work with them as well. But because 3 does not go into 25 or 65 evenly, we are going to just work with our 48 until we get to numbers that work with the 25 and 65. Okay, so 48 divided by 3 is 16. 16 divided by 2 is 8. And then we have 8 divided by 2, which is 4. Okay, and then when we go to 4 divided by 2, we get 2. So that's as low as we can get with our prime numbers. We want to get our givens down to the lowest prime number that we can get them. Okay, so now that stops us there. So we go over to our 25 and we break it down. 25, well, I did 65 first, so we'll go to 65. Now we break down our 65. I decided to do 65 divided by 13, which gives you 5. So that's as low as that'll go. And so that leaves us with a 5. So now doing 25 divided by 5, which is a prime number, it gets us down to 5. So our least common multiple is, you go to find that, you go and you count the numbers on the far left side and the bottom. So we'll start with our 2s. Okay, so there's 1, 2, 3, and 4. So it's 2 to the 4th times 3 to the 1st times 5 to the 2nd. Now, there's 3 5s here, but on your bottom row, if there is more than 1, you only count it 1 time. So say there was 3 5s, you would only 3 5s at the bottom. You would only count one of the 5s at the bottom, but you will count all the numbers on the side. No matter how many there is, you'll count all of them on the side, but only count one of the numbers at the bottom if there's multiple of that number. Okay, so you'll have 5 to the 2nd power and times 13 to the 1st power. So that's how you get least common multiple. Okay, so now we've got 40, 12, 44, and 363. So what I did here was I started out with 2. So 40 divided by 2 is 20, and then you can do 12 divided by 2 is 6, and then 44 divided by 2 is 22. Didn't do 363, we just left that one. So then we continued on down. So 20 divided by 2 gives you 10, 6 divided by 2 gives you 3, 22 divided by 2 gives you 11. So now we see that 2 of our numbers are dropped down as low as they can go in the prime factorization. So we have 3 and 11. So now we still have a 10 and we still have our 363. So if you divide 10 by 2 again, you get 5. And that's as low as that'll go in the prime factorization. So now we'll focus on our 363. So 363 divided by 3 gives you 121. So now 121 divided by 11 gives you 11, and that is also dropped down as low as it'll go in prime factorization. So our least common multiple is, we'll start with our 2's, 1, 2, and 3, 2 to the third, and then we have 3, 1, 2, 3 to the second. We'll have our 5 to the first, and then we'll have our 11, that's supposed to be to the second, I'm so sorry. And then you'll have 11 to the second. Okay, on to the next one. Okay, so now we have, okay, so that's supposed to be changed up here, but we won't worry about that. Okay, so now we've got, our numbers are 250, 28, 44, and 110. So here's how we're going to do this. You can start out, I start out with doing 2's on this one. So I divided by 2. So 250 divided by 2 is 125. 28 divided by 2 is 14. 44 divided by 2 is 22. And then 110 divided by 2 is 55. So I decided to do divide by 2 again, because here you can't divide by 2 because it won't break evenly. So you just leave that one alone and you drop it down. Okay, 14 divided by 2 is 7. 22 divided by 2 is 11. So those are already broken down to as low as they'll go in the prime numbers. So now we can go ahead and we know 5 will go into 125. So 125 divided by 5 gives you 25. And then you can break it down again, and 25 divided by 5 gives you 5. So that's as low as it'll go. And then over here with our 55, if you break it down by the 5, it gives you 11. And so that is as low as it'll go. So now we have 2 to the second power, 1, 2. And then we have 5 to the third, 1, 2, 3. And then you have 7 to the first, and then 11. 11 should be to the first, not to the third. All right, and 11 to the first power. Okay, on to the next one. Okay, how many rotations does it take for the small gear to get back to its original spot? So, find the least common multiple of both gears. So here's what you'll do. A equals, what you're trying to do is you're trying to find the multiples of 48 and 84. So multiples of 48 are 48, 96, 144, 192, 240, 288, 336, and 384. So now 84 is 84, 168, 252, 336, 420, 504, 588. So now, what is the least common multiple that they have in common? Well, it looks like it's 336. So what you'll do now is 48 and 84, its least common multiple is 336. And so find how many rounds each gear needs to get back in the original position. So you'll take their least common multiple and you'll divide it by how many rounds each gear, like you'll divide it by how many teeth each gear has. So it's their least common multiple is 336, and you divide it by the 48 teeth of gear A, which means it'll take 7 rounds around gear B for gear A to get back in its original position, its original starting point. So now, to figure out how many rounds it'll take for gear B to go around gear A and get back to its original starting point is 336 divided by 84. So that'll give you 4 rounds. All right, on to our next subject, our magic square. Okay, so for the magic square, you must have a magic number, but how do we get the magic number? Okay, so you add up all the given numbers that are supposed to be inserted into the magic square and divide that number by 3. -9 is your magic number, so each row and column need to add up individually to -9. So we're given our list of numbers, which is -7, -6, -5, -4, -3, -2, -1, 0, and 1. So each row and column need to add up individually to -9. So when you add all those numbers together and you divide them by 3, it'll give you -9. In other magic squares, it'll give you another list of numbers. You'll add those up, divide them by 3, which it'll come out different, but this is a 3 by 3 square. If they use anything different than a 3 by 3 square, like a 5 by 5, then you'll divide that by how many squares you have in each row and each column and diagonally. Okay, so now, what sets of numbers add up to -9? So you're trying to figure out like where to place your numbers now. So it's best to figure out what numbers add up to your -9. So -2, -7, -4, -5, and -6 and -3. So you just take any of those and you just decide where to place them, because the magic square is more of a trial and error, especially when they only give you two places and they're completely separate from each other. So you have a 0 here and you have a 1 over here. So if you can place your -2 and your -7 with your 0, and where your -7 is above the 1, and then you can place your -4 and -5 vertically with your 0. Okay, so now your first column and your first row, they both equal -9. They both make -9. So now all you're trying to do is put in your bits and pieces for your numbers. So now take what you have to find the missing pieces. So now we have -7 plus 1, which gives us -6. And then when you do -9 minus -6, it gives you -3. So you'll put in your -3. Okay, so now -5, we have our -5 here, and then now we have a -3. So what we can do is -5 plus -3 equals -8. And so to find that, you take your -9 and you minus your 8, which gives you a -1. So that means our -1 can go right here. And then now our last number that we have not used is our -6. And so you can go through and your -6 plus -2 is -8, and then -1 out of that is -9. So you can add up your numbers every which way, diagonally, vertically, horizontally, and you will get -9. And that is how a magic square is supposed to work. Okay, let's see. All right, and that concludes my PowerPoint. Thank you all so much for watching. I hope you enjoyed it, and y'all have a wonderful, wonderful evening.